Hi everyone. In this video, I am going to be going over the hands-on labs from Chapter 12 out of the CCNA Routing and Switching Study Guide written by Todd Lamel. Chapter 12 is all about security, specifically ACLs, access control lists. So there are two basic types of access control lists. You have a standard access list and an extended access list. So we're going to look at comparing the two of them. We're going to go ahead and configure a standard access list and test it, and then we'll remove it and apply an extended access list, and we'll see how you can get a little bit more granular, a little more specific controls with an extended access list. In addition to your numbered access lists, there's also a variant on the same access list, but you're using a named access list, so you name it rather than assign a number to it. And that can be a little more beneficial from the administrative side. If you have multiple access lists, it's a lot easier to name it something pertinent to whatever the access list controls than to try to memorize that this number means this access list and this number means that access list. So named access lists can be quite a bit more beneficial. I'm not going to go into the named access list in this video, just the numbered, standard numbered, and extended numbered access lists. So let's go ahead and get started. The first thing we want to do is have our network built. This basic topology is depicted in the book. My only modification is that I added an extra PC via a switch to each LAN. That way I have two devices on each LAN, so I can really make sure my ACLs are working properly. Another thing the book does not mention is configuring your routing protocols. So if you are following me along in Packet Tracer and working through this, remember that you need to set up some routing protocols to get connectivity between your two LANs. If you're doing this in a physical environment, you will probably need to do the same thing, set up some form of routing protocol. I went with OSPF because I think it's probably what I'm the most comfortable with. It's quick and easy to set up. So we want to verify that we have connectivity both locally and across our routers. And in Packet Tracer, your first ping will always fail as it builds the ARP tables. Your second and subsequent pings should all be successful once each device has actually communicated some form of traffic on the network. And coming back the other way should also likewise be successful. Alright, so we know we have connectivity. So one thing that we want to do is, to begin, we want to go ahead and block access between our two LANs. So we're going to start here in the LA router. And so we're going to work through this kind of one step at a time. So we know we're going to set up an ACL, so we want to start with the command access list. And then here's our two options, our standard or our extended. So our standard is numbered 1 through 99, and our extended is numbered 100 through 199. Since we're going to start with the standard, we just need to pick from this pool of numbers. I like 19, so that's what I'm going to go with. Alright, and the next thing that we want to do, we want to give the permit command. And let me move this for a second. We're going to specify this machine's address, which in my network is 192.168.20.2. And then we want to give a wildcard mask. So we're used to seeing our subnet masks, for example, a class C would be 255.255.255.0. For the wildcard mask, we need to invert this subnet mask. So instead of being that, we would see this. And if we're going to apply a wildcard mask based on a full network, then we wouldn't want to specify a specific IP address. We would want to give the network address. Since we are applying for a specific IP address, a specific host, we want to go ahead and lock that down to 0000 for the wildcard mask. and that specifies that only this IP address will be permitted based on our command, rather than controlling by an entire network or an entire subnetwork. We want to lock it down with this specific address. Alright, so in a nutshell, that's it. That we've created that access list with that single command. The next thing that we need to do is to apply that access list to a specific interface. So we want to look and we want to apply that as close as possible to this PC. And so the closest interface on our router is G00. So we're going to set it as outbound on G00. So we want to get directly to the interface, and then we want to give the command IP access group, and then the number. The last thing that we want to do is define whether it's inbound traffic on that interface or outbound traffic on that interface. And we're going to specify outbound in this situation. Alright, so we can see that it's been applied. We have a few commands to help verify it. So the first thing that we can do is give the command show access list, and that will show me all existing access lists on this router. That's the only one we've created, so that's the only one that we see. We also see the entry that it will permit 20.2 on outbound traffic. We do have a few other commands. You can issue a show run and find G00, and we can see that it has been applied to that interface. I had a friend recently take one of the Cisco certs. One thing he mentioned is you really need to know your troubleshooting commands. For example, your show commands, whatever they're related to. So I want to spend a little bit more time on that with this specific video, because you can't always count on having every single command available, so you need to know multiple ways to get the information. So we've done the show access lists, we've done the show run, we have a couple of other alternatives. So we can give the command show access list and then the specific number, and we can see the commands that are listed, or the entries, and so it would list them all here. Another command that we have at our disposal is show IP access lists. So again, we see the access list number as well as the entry within it. If we had multiple entries, remember that access lists are a top-down, so the first command you enter will be at the top, every subsequent command will fall underneath, and the way the access list will work is as traffic is coming across the router and goes to this interface, that packet will be compared to the access list. And so the top-down infrastructure applies, so that packet will be compared to the first entry. If it matches, it's allowed through. If it doesn't match, then it moves to the second entry, and so on and so forth. It'll move down the list one entry at a time until it finds one that it actually applies to it. If you don't configure any commands that apply to that specific packet, then there's an implicit deny at the end. Even though you didn't give a deny command, there's an implicit deny. So if it doesn't match anything else, it gets to the end of the list, there's no additional entries, it hasn't matched anything, it will automatically become blocked and will be dropped there. So that is one thing to keep in mind with your access lists. You may accidentally end up blocking more than you anticipate. Alright, so we can go ahead and test to see if our ACL is working, which it looks like it is blocking traffic. We can verify that it wasn't just blocking one PC, it's blocking both because they're on this LAN. It's blocking pretty much everything to that PC. Looks like it's blocking everything to this whole LAN. And we can verify that we're reaching the router, and that our ACL is blocking inbound traffic to our LAN, because it's actually outbound on that interface, and so it's being blocked. We can go ahead and view that in simulation mode and follow that packet one step at a time. We see it reach the router and gets blocked by the ACL. So let's clear that, and let's test one that originates here. We'll see it makes it all the way over to the destination, and on return it is still blocked. So even though the machine on this LAN initiated the communication, our router, because of that ACL, is still going to block it. So it can get a request out, but will never get any kind of response. Alright, so back to real time. Alright, and it looks like that's pretty much all the content that they wanted covered for the standard access list. Next, we're going to jump into the extended access list, which is 12.2. The first thing that we want to do is to remove the existing access list. And then we want to verify that the access list has been removed. Alright, so we get no output from that command, which means there is no access list created on the router now. And that's a good thing. We can also verify by trying that ping again. And we have success. We're no longer being blocked by the access list. Alright, so we have full communication available again. Now we want to get a little bit more granular with extended access lists. We're going to do this closer to the source rather than destination here. So we're going to start on the SF router. And what we're going to be doing is creating an extended IP access list to prevent the host here at this address, 10.2. We want to prevent telnet to the LA router, which is here. It should still be able to ping, but we just want to block telnet, which realistically we should have telnet disabled on our routers, and we should be using SSH for security purposes. But understanding the process, you could then set that up to block SSH from this machine instead of telnet. There is a note in the book here. It says, pay special attention to the log command. It is a Cisco objective. Once I get to that, I will place some extra emphasis on it. Alright, so we've removed the standard ACL off of LA. We're going to come into SF, and we're going to begin creating our extended ACL. So again, we're going to need to pick a number out of that range from 100 to 199. So we're going to create our access list. I'm going to go with 119 now. And we're going to start by explicitly denying traffic. And we can look at our options. Telnet is a TCP protocol, so that's where we're going to start. And then we can view what else we have. So we have source address. We can use that if we want to apply this deny command to an entire subnet or an entire network. We can apply the any if we want to block absolutely everything, regardless of its source. And we can deny by host if we have a specific single machine's IP address that we want to block. If you are doing it that way, you'll likely want to have a network with at least some static IP addresses, because if you block an IP address for a machine and 3 days later it picks up a DHCP address that is a different address, it will no longer be blocked by the ACL. So if you are going to do a single host, you may want to verify that it is a static address on that host. In this case, we are doing a single host, so we'll give the host command, and then it'll ask for the IP address that we want to block, which is the 192.168.10.2. and we want to prevent it from reaching a specific host. So we give host again, and then we give the IP address that we want to block it from reaching, which in this case, the first port it'll connect to on the LA router is the 172.16.10.4 network. And so corp is 10.5 and LA is 10.6, so it'll be 10.6. And then we can hit our question mark to view what else is necessary here. So we can do EQ, which will be packets on a specific port number. We know the port number for Telnet and SSH, and if we don't, we can look that up pretty easily. In this case, we're going to be blocking, and let's go ahead and drop EQ, and we can continue. I think we can still get some more information there. So we can put in the number, the specific port number, which it actually tells us right here what port number Telnet is. Or we can just give the word Telnet or www port 80, HTTP, HTTPS would be port 443. You can get a list of port numbers from the internet in hundreds of places. In this case, we want to specify Telnet, just like that. And now we're at that point where I said I would give a little extra emphasis. There's another command that we can add to the end of this. We could enter and apply it just like this, or we can also tell it to log, which will log anytime this rule is hit. So anytime this specific host tries to telnet to this specific host, it'll log that information and say, the ACL has been hit once each time, and it'll keep adding a +1 on there. So that way we can see how many attempts have been made and how many times the ACL has blocked that telnet connection. So we'll go ahead and hit enter. Looks like Packet Tracer won't allow me to log, which is unfortunate, because it certainly should, as that is covered. It's definitely an objective if you're going for certification. Being able to have it log and view those logs. Looks like I won't be able to show that in my video, unfortunately, but it is important to know. So that is the command you would give. Right now I'm just going to go ahead and finish by setting up the access list. So with that command, we've denied that kind of access. The next thing we want to do is to permit anything else. Otherwise, there's that implicit deny all at the end of our access list. So we want to go ahead and permit all IP traffic from any. There we go. Sorry. So this way, we will only be blocking Telnet from this host to this host, and we'll be permitting absolutely everything else. So that way we're not inadvertently blocking more than we intended. This is the same as any. This is all available IP addresses. So we could change that to just say any. I believe that is another objective, learning point, I guess, with Cisco, is understanding that these are one and the same. Remember, that's the wildcard subnet mask, so it'll apply to any. A lot of times you'll just see the command given any, just like that. Alright, so we want to go ahead and apply our newly created access list. So we want to do this as close as possible to the source, which is going to be here, from this PC. Our closest router interface is right here. So we want to go ahead and jump into the interface. We want to give the command IP access group 119 inbound, so anything in on that port. And then we want to go ahead and try to telnet over to LA. Got no response, which means it's being blocked. I think even if we check that in simulation, we can view it reaching out and being stopped at the SF router. Alright, so let's try it from our other PC. Well, and here we see that it was closed. I don't have telnet configured. I don't have any password or anything set up, so let's do that. We'll just create a password on it and enable login. And now I'm in. But again, even from our blocked PC, because of the ACL, we will just get no reply at all from the targeted router. If our packet tracer would allow us to log infractions or attempts that are blocked by that ACL, we should see output on here every time that the ACL had blocked, a specific packet. Let me grab a notepad here. And so if we were able to configure logging to work properly, then we would expect to see something like this. And these would just be system messages every time it blocked that connectivity. So that would show us that it blocked the first, and then it blocked the 3 follow-on. So that's what you would expect to see if logging was working properly. Alright, I think that covers pretty much everything. Sorry I couldn't show the logging. I did quickly pull up a few other routers and test it. Doesn't look like logging is supported in Packet Tracer on any of the routers. This may just be a limitation with the version I'm running. Perhaps that's something they'll implement later. But just a quick recap, we went over a standard numbered access control list on LA, closest to our destination. So when we attempted to ping from this LAN over to this LAN, it was blocked, so it was closest to the destination. If we'd put a standard numbered access list closer to our sources, then we would block all traffic from them reaching out to the internet. We're assuming the internet would be out here, most likely. So a standard numbered ACL you want close to your destination, so that way you're not blocking a ton of traffic to other destinations. And then once we had tested that and it worked, we went ahead, removed our ACL, and then configured an extended ACL. And so the extended ACL we want close to our sources, so that way it's blocked before it creates a bunch of network traffic unnecessarily. So that way we didn't have that telnet traffic coming all the way across our network, creating overhead for this traffic that just then got blocked right here. So that we were able to block it early. So that is kind of a key difference that you should keep in mind with your ACLs, is that a standard ACL should be applied as close as possible to the destination, while the extended ACL should be applied as close as possible to the source. As always, if you have any questions or comments, please feel free to leave them for me below. Thank you so much for watching, and I hope to see you in my next video.